Okay, so we've been doing quadratics, right? Quadratic modeling. We're going to throw in quadratic inequalities. We're going to do it on Monday as well. This is kind of like an intro. So let's just read what's going on here. We have the height of the main support cable on a suspension bridge is defined by the function. Okay, so we have the function where x is the horizontal distance. So we're not talking time here. We're talking horizontal distance. We know that happens sometimes. That's in feet. And then we have our height, which is also in feet of the cable. Part A says, where is the bridge cable height less than 40 feet? So can it be 40 feet? That's my first question. Can it be 40 feet? Does it say less than or equal to?
No.
No, it says less than. Okay, so we want it to be 40 or less. We're going to draw a horizontal line at y equals 40. Okay, so we want to know, imagine that this is like the actual cable, right, and the cable height, okay? So we want to know, when is it below 40? Now on our graph, if you're a highlighter person, grab your highlighters, okay, because this is a great lesson for that. We're looking right here. We're looking when it's below that 40 feet. Now we have to determine what are the x values that it's between. So if we kind of draw these lines down, okay, those are our x values where it's below 40. Tracking so far?
Yes.
Okay, so right here we can estimate that, okay, and we can estimate that. They're not perfect, but we're going to use our calculator to get the exact values. Okay. Now, if we're talking about an inequality, this is kind of like when is like on our quadratic modeling, when is something decreasing or when is it going down? And you would state from 2.5 to 5. When we write that, we write it like this, right? Something less than x less than something, and we're saying x is between those two values. Okay, so we're going to go ahead and estimate these. So if I would say halfway would be 30. You want to say 25? Does that look good for 25? Mm-hmm. Okay, so we'll put 25 there. Okay, and then what do you want to say for this one? Yeah, probably like 65. I would say like halfway would be 70. We'll go 65. If you want to say like 64, 63, whatever, something around 65. So those are estimated. Okay, and we're going to actually graph it and find the actual numbers. They'll be pretty close to those. Now, for our y1 that we're going to enter in our calculator, we want the quadratic. So we're going to use the function that they gave us. Okay, and then what do you think our y2 is going to be? Our second equation that we're going to enter. What do we draw up here? Or what did you draw on your graph?
A horizontal line.
A horizontal line at 40. What is the equation of a horizontal line? Not x equals. We're talking a y value there, friends. Y equals 40. Okay? So in y2, you're just going to simply put 40, because that's like y equals 40. Now, before we go typing it in, let's pick out what our scales should be. So for our x minimum, what do you think our lowest x value should be? 0 looks pretty good. Same thing with y, right? Let's just look at the graph. 0, 0 is fine. Now, what do you think for the x max, y max?
100.
I would say 100 for both. That's what shows up on the graph. It looks fine there.
Wait,
so
are you looking at like the part you highlighted for like the x max and y max?
No, we're just looking at the whole graph.
Okay.
Yeah, we're just graphing it. Yep, we're just graphing it. All right, our x scale. This goes by 20s. I think that's a little big. Why don't we go by 10s on x and y? We'll just go by 10. If you left it at 1, you would probably be fine. It would show up okay. But when we go by 10, when we trace it, it doesn't have to go. It doesn't take this long. Okay, go ahead and go to your calculator. Okay, we're going to go to y equals. Okay, and we're going to put in y1 what we wrote down. Okay, and then in y2, what are we putting in y2? 40. Okay, do we have our window entered? Probably not. Mine might be okay. Okay, mine's already in there. But go ahead and put in your window based on what we wrote down. All right, and we're going to hit graph. Go ahead and hit graph once you get there. Okay, what's awesome about this is now we can see the parabola, and we can see that y equals 40 line, and we can see the intersections. We haven't used this feature yet on our graphing calculator called intersect, but we can. So we're still going to do second trace. That's kind of where we live for when we're tracing things on a graph. But number 5 says intersect. So go ahead and choose number 5. Okay, we don't have to do left bound, right bound. That's what we're used to doing. This is called first curve and second curve. So we're going to move over, okay, to that first intersection on the left-hand side. Okay, and you just want to be somewhere close to that intersection. Oh, mine's going to keep going. Okay, that's pretty close. That's good. And hit enter. And now it says second curve. But your graphing calculator is going to almost just automatically jump to that second curve or that second line. And it's fine where it's at, so just press enter. Okay, and then it says guess. We're used to that. We go right on where we think that intersection's at and press enter. And so it gives us the intersection. The intersection, we'll go ahead and round it to 23.4, comma 40. Now we know that the y should be 40 because it was a y equals 40 line, but the x is what we're really interested in, that 23.4. So go ahead and go back to your notes here. Okay, and our actual number was 23.4. We originally guessed 25, but it is 23.4. Questions on finding the intersection? Okay, let's do it on the second one.
Wait,
Oh, go ahead.
so do you not know what goes after the other little...
We're going to find that, right? We just found that one. Now we have to trace the other one. Yep, we're going to go back to our calculator and trace the other one. So now we're going to do second trace again. What do I choose here?
5.
Number 5, intersect. Okay, so now we're going to go over, we're going to use our arrows to go over to the other side. So we're close there, so we're going to press enter. And that's close enough. We really don't have to get much closer. Press enter, and then go over for our guess. Ooh. That looks pretty good. All right, so 64 point, we'll round that to 1, 64.1. And then our y value is 40. So that's that intersection point. Again, we don't really care about the 40. We knew that was going to be 40, but we do care about that 64.1. So back to our notes. Okay, and the actual value there was 64.1. We guessed 65, which was close. Okay, questions on getting the intersection? Okay, now all we have to do is put it on a number line. This is kind of like Algebra 1. You just plot them. But before we do that, I want to talk about why we used a less than symbol and not a less than equal to symbol. Okay? We said originally that it wasn't equal to 40, it was just less than. Yes? With me on that?
Yeah.
Okay? It was just less than 40. That's why we don't put an equal to on those. Okay? If it said 40 or less, then we could have put an equal to there. So whenever we have not equal to, we just have less than, what type of circle do we plot on a number line? Open or closed?
Open.
Open. So at 23.4, you're going to have to kind of round it there. At 23.4, you should have an open circle. And then at 64.1, almost 65, you should have an open circle. And then you shade in between, because we're saying x is between 23.4 and 64.1. Questions for me? You tracking? You guys are not talking. Okay. Letter B. Now we're going to look at something different here. Okay. The last time we were underneath. Okay, and we're going to see what happens here. Where is the bridge cable height? At least 60 feet. So now we're going above. We're going above. So when it says at least 60 feet, Are we going, could it be equal to 60?
Yeah.
Yes, because it's at least 60, right? So 60 or above. So go ahead and draw your line at 60. Okay, now it's at least 60, so we're going to go above the graph this time. So if you have your highlighter and you want to highlight, okay, we're going above. So we're here and we're here. Okay, those sections are above 60. Okay, from the rest, it's kind of the same, okay, but our inequalities are going to look different this time. If we're talking about this section of the graph, and I want you to focus on x values, okay? Over here, on this left-hand side, we're going this number and less. You with me on that? Because it's x values, this number and less. So we could guess that this is about what?
15.
You want to say, okay, 15, 17, whatever you want to write down there is fine. What would you guess here?
75.
Yeah, 75 is good. Okay, that's rough, but it's good. All right, so if we're looking at this 15, okay, and we want to go less than that, our setup would be x is less than or equal to some number. Okay, we'll get to the 15 here in a second. Or, okay, and then over here, you're saying 75, but what are these numbers to the right where we're highlighted?
Greater.
They're greater than. So x is greater than equal to some number. How do I know it's equal to?
Because it says at least.
Because it says at least 60. It could be 60 or more. Okay, so if we want to do our estimated solutions, okay, we would say x is less than or equal to 15. We guessed 15. Or x is greater than or equal to 75. So now we have two sections of our graph as opposed to one. Okay, now we're going to do those intersections again. Okay, so we're back to our intersections. The good thing about this is you already have the equations in your calculators, okay, but we have to change one of the equations. Y2 is now going to be what?
Y equals 60.
It's going to be 60 instead of 40, okay? So let's jump back to the calculator. We're going to go back to y equals, and we're going to edit that 40 to be 60. Okay, and then we're going to hit graph. Okay, now remember, okay, we're working with the part that's above, but that doesn't really affect our intersection. We just want to find the intersection. So we're going to hit second, trace. What are we choosing? Number 5, intersect. Okay, and then we're going to scroll over and do our first curve as close to the intersection as we can get. Okay, enter, and then second curve, enter, guess. All right, let's say about 13.5. Got it to 13.5, comma 60. Go back to our, so we have x is less than or equal to 13.5. So we guessed 15, we were a little off. Okay, and then we'll have or, and then we're going to do our second intersection. So second trace, number 5, and we're scrolling all the way over. Press enter. Okay, second curve, enter, and then our guess. All right, that one's about, I would probably round it to 74, because if we have 0.98, we'll be at 74.60. Any issues on getting that intersection? So that one would be x is greater than or equal to 74. All right, when we have less than equal to or greater than equal to, what does that mean for the dots on our number line?
Colored in.
Yep, they are closed or they're colored in. So let's go to 13.5 first. Okay, it should be a solid dot there. And if it's x is less than, am I going to shade to the left or to the right? To the left. Okay, if you need a hint, okay, look at your inequality sign. Okay, that arrow looks like it's pointing to the left on the inequality sign, so you shade left. And over here at 74, it looks like it's pointing to the right, right? And these are the greater numbers, so we shade to the right. Okay, so we're going to debrief before we move on. Number one had one section, right? We were looking at one section of the graph. You with me on that? Okay. Look at our inequality, right? It was just one inequality down here. Okay, this was just one inequality. That's going to be consistent. If you're talking about one section of the graph, you should have one inequality. Okay. Now on the right hand or on part B, okay, we were talking about two different sections of the graph. So we have two different inequalities with or in the middle. Yes? Okay? And that should also be reflected in your number line. There should be two sections on your number line then. Okay? Ready to move on? Okay, here we go. Example 2. Consider the quadratic inequality. X squared minus x minus 6 is less than 0. Which of these graphs would you expect to represent g of x? Okay, we don't even need our graphing calculator. Does anybody have an idea which graph would work and why? Graph 1. Why do you say graph 1? Right, it's not a maximum. Take a look at your x squared term right here. That x squared term is positive, meaning your graph is pointing up. Okay, so if you need to make a note of that, do that. Okay, we know based on that starting term that the graph points up. So it should be graph 1. Okay, our leading term is positive would suffice for a reasoning. Okay, part B, I already factored it for you. Okay, so your standard form, and then I factored it, it's x minus 3x plus 2. It says explain how factored form helps you to solve the equation. What does factored form give us that standard form doesn't? The x-intercepts, right? We get the x-intercepts. We get the x-intercepts. Okay, so if I have x minus 3, what x-intercept is that? 3, positive 3, okay? Because what we do is we take x minus 3, set it equal to 0. We add 3 to both sides. That gives us x minus 3. Okay, so if I have x plus 2, what x-intercept is that? Negative 2. Yeah, we just flip the signs on those. All right, now we're going to go to our inequality piece here. It says solve your equation and give your solutions in both symbolic form and number line graph. Okay, so I want you to think about our answers 2 and 3. Okay, and our sign is less than. So if we know that the graph is pointed up, okay, and it's from negative 2 to 3, we're going to be here. We're talking about a low point. Okay, so we're going to write negative 2 to 3 for our set notation. And you could use your graphing calculator to look at it and make sure you know what you're talking about. But if it says less than 0, we're talking about something below the y-axis. It's less than 0. Y is below the x-axis. Okay, our number line solution. If we have equal to, what's that tell us about our dots? They are closed. So you have a closed dot at negative 2 and a closed dot at 3. Shade in between because we have one section. Okay, now, do you remember going from inequality notation to interval notation? Remember intervals with your parentheses and your brackets? Yes? What does equal to mean? Does that mean parenthesis or bracket? Bracket. So if we want to write interval notation, we would say -2 to 3. Both of them would have brackets on them.
Wait, does infinity have parentheses?
Say that again?
Infinity has parentheses.
Yeah, infinity will always have a parenthesis. Yep.
Can this like go on to infinity?
Yeah, that's because it can be equal to infinity.
Right.
Can that
We
go
don't-
on to infinity?
What?
Like, can there only be one point in it? Can it go on or no?
Not on these.
Okay.
Okay, part D. Now we flip the sign. Okay, now our sign is a greater than sign, but there's no equal to there. Okay, there's no equal to. So I want you to think about the graph. Okay, right here from -2 to 3, it was below the x-axis. Okay, now we're talking about above the x-axis. So we're talking about right here, and we're talking about right here. Okay, so this -2, we know that's going to go here. Okay, but am I talking about numbers that are less than -2 or greater than -2? Less, right? This red arrow is pointing to the left. It's going to lesser values. So we want x to be less than -2. How do I know it's not less than equal to? Because our original sign over here is just greater than. There's no equal to there. Okay? Now, for x in 3, which way am I going for 3? Positive or negative? Positive, right? 3 and to the right, those are bigger numbers. So this will be x is greater than 3. All right, so x is less than -2. Open circle at -2. Which way am I going to go? Left or right?
Left.
Left, because it's less than. And then 3, and it's x is greater, left or right?
Right.
Right. Okay, so again, 2 inequalities, 2 sections. Okay, 2 sections of the graph. It should always line up. 2, 2, 2, 1, 1, 1. Okay, now it gets a little tricky for our interval notation here. If we're talking about x is less than -2, how do we say that in interval notation? Are you talking about numbers greater than 2 or less than 2? How do we write all numbers less than -2? Negative infinity. So that's negative infinity to -2. Infinity always gets a parenthesis. 2, what does it get? Does it have equal to? No. It's just x is less than right here. It's just x, it's just x is less than. Okay? So that should get a parenthesis on it. Okay, and we use a U to show or. Okay, and then x is greater than 3. How do I say that?
You put down 3.
3 to
Infinity.
infinity. Okay? It's been a while since we did that stuff. Okay, we're going to cover a lot more of this on Monday. This is just kind of like an intro. All right, your answers to questions in example 2 show 2 key ideas. Okay, we talked about 2 key ideas just now. Where we have less than, okay, and we have greater than. The first part here says, how does sketching the graph help in solving a quadratic inequality? Like if you didn't have the sketch, what could you not do? How does it help us to look at the graph? Sir? Yeah, it helps us to know, okay, if we're talking less than, then we're talking below, right? If we're talking greater than, we're going above. So it helps us to visualize which section of the graph we are looking at. How does solving the equation, okay, now when we say solve, what's another word for solve when we're talking about a quadratic? Did I hear it? Factor. Okay, which we so nicely already did for you on that one question. But how does factoring the equation help us to solve an inequality? What is crucial about that factoring piece that we get? What's the x-intercepts? Yeah, x-intercepts. Oops. So if we're looking at a graph, okay, and it crosses, we need to know these points in order to write our inequalities. Those x-intercepts are part of our inequality. Okay, questions for me? Good deal.